Throughout the world, pulp producers recognize the need for environmentally friendly solutions for optimization of their batch pulping processes. The need for optimization is driven by cost, quality, production, and safety. The need for added capacity and the difficulty of permitting additional vessels drives mills to look for added capacity from existing digesters. Pressures from a very tight marketplace are forcing mills to cut costs while improving quality. As competitive pressures mount, many mills are expanding into new markets, adding the complexity of multiple grades and frequent grade changes. Most mills are faced with the task of retrofitting existing digester houses. Establishing accurate costs and realistic expectations are at best difficult under these conditions. Orion, a leader in process control solutions for the pulp and paper industry, can assist your mill in solving these complex issues. Innovative designs, proven experience, and total installation capabilities demonstrate Orion's unique and unprecedented ability to supply fully integrated automation solutions. In the next few minutes, we will provide you with an overview of Orion's CyberCOOK technologies. CyberCOOK eliminates the guesswork in Kraft batch digester control. CyberCOOK is a control, optimization, and reporting system for your Kraft digester house. The key benefits associated with CyberCOOK are reduced cook cycle times of up to 15%, reduced digester idle times of up to 25%, reduced chemical consumption up to 10%, reduced steam consumption up to 12%, increased production of up to 7%, improve pulp quality up to 50%, increase yield up to 2%, reduce wood up to 4%, reduce steam flow variation up to 90%, and improved environmental compliance. Your benefits are dependent on specific mill operations, instrumentation, and conditions. These can be determined in an Orion Phase 1 study. CyberCOOK controls and monitors all sequences from the chip belts to the final blow. Operator permission checks can be provided at any stage in the cooking sequence. The main functions of CyberCOOK are control of chip filling, liquor filling, cooking, relief, and blowing, as well as digester scheduling control, steam limiting and smoothing control, and cap and number variation control. Additionally, CyberCOOK offers pulp quality control and digester channeling analysis. Orion has extensive experience in batch digester operations and control. Gary Jones is a senior consultant with Orion.
As chips are conveyed into the digester, they pass over a weigh cell. Chips moisture is measured periodically offline or in some cases online. From this moisture measurement, CyberCOOK then calculates the dry weight of chips added to the digester. Based on the maximum dry weight allowable or the maximum chip level allowable, CyberCOOK then stops the chip conveyor and starts the next phase.
Patrick Charles is an Orion senior design engineer.
Liquor filling can be performed concurrently with chip filling for liquor packing or after chip filling is complete. CyberCOOK monitors and controls liquor filling pumps, valves, and flow rates. It starts liquor filling, monitors liquor flow, then stops liquor filling based on the target alkali to wood ratio and liquor to wood ratio.
After the digester has been charged with chips and liquor and permission has been given to steam the digester, CyberCOOK controls the digester temperature rise and starts the cooking model calculations.
Dr. Igor Aronov is a senior consultant with Orion.
There are 4 phases of cooking: the chip delivery phase, the bring up phase, the cooking phase, and the blow phase. During the bring up and the cooking phases, liquor is recirculated to an external heat exchanger to maintain liquid temperature. The cooking progress is determined by the cooking model. It is a very important point in our optimization system. The cooking temperature ramps up to a maximum value, at which point it is held for a period of time. This period of time is the cooking phase. The cooking model determines that the cook is complete. At that point, CyberCOOK initiates the next phase in the scheduler.
CyberCOOK checks a number of conditions before a digester is blown. Most important is whether the cooking model target has been reached.
Alan Womack is an Orion senior consultant.
CyberCOOK's scheduling algorithm is designed to minimize the interval between the digester phases, to avoid conflicts in the blow scheduling, and to maximize the overall production of the digester house. CyberCOOK can both meet your production targets and provide your operators with the flexibility to easily adjust the production schedule due to external influences.
Dr. Ray Kirby is the manager of cyber product development.
One of the most interesting challenges in digester control is that of temperature. The ability to follow the nonlinear cooking curve, which is defined for each grade, is really a challenge. We accomplish this in CyberCOOK by using a fuzzy logic algorithm that allows us to follow the cooking curve very closely and avoid any overshoot. Obviously, any overshoot would cause us to overcook and would be less efficient in steam usage. Since fuzzy logic is a matrix of nonlinear control laws, it's an excellent solution to the temperature control problem.
Vito Krzyzlowski is the product manager for CyberCOOK.
What is really unique for CyberCOOK and completely separates CyberCOOK from other products on the market, it is optimization function of total quality and production control. CyberCOOK is smart enough to modulate steam distribution within digester to achieve stable pulp quality throughout digester and prevent liquor channeling.
All Orion cyber products incorporate an inherently operator-friendly interface, assuring that not only does our product perform its job, but that your mill and its employees are able to use the cyber technologies to their fullest.
Orion provides comprehensive operator training on site with high-fidelity process simulation. Also, we typically require operator input in the development of the functional specification, which drives the control system interface design.
Bob Bowers is a senior project manager with Orion.
There are three key elements to a successful digester project. The first is to develop a good definition of the project. With that, I mean understanding what the project goals are and the expected results, as well as having a well-defined scope of work to be accomplished. These are the items that Orion can certainly help a customer achieve with the Phase 1 study at the initial phase of the project. A second key element would be to assemble a strong implementation team. It's important to have experienced personnel in the areas of controls, control system components, and the applications specific to the digester process. These are certainly the strengths that Orion can bring to a project. And lastly, the organization of the project. It has to be set up to succeed. All the team members, including the customer, the engineer, and the contractors, need to be dedicated to the successful completion of the project.
All Cyber Series solutions have one common objective: providing a substantial return on your investment through advanced automation of your mill, assuring optimum cost, quality, safety, and environmental performance. CyberCOOK will substantially improve product quality while minimizing environmental impact and reducing production costs for your mill.
Thank you for sharing your time with us. Our commitment to you is a successful project. We have advanced technology and many years' experience in accomplishing turnkey delivery. In our Phase 1 study, we defined the best area for return on investment for your mill. We guarantee it. Please let us know what we can do for you.
CyberCOOK systems, when integrated with other Cyber Series solutions, will provide unmatched performance in cost reduction, reliability, and regulatory compliance.